also called nodes or points, also known as nodes or points, also known as nodes or points. PTS means points. Finite of E edges. A finite of E edges. E means edges. EDS. Also called arcs or lines. Also known as arcs and lines. So lines. A mapping F from the set of edges. Mapping F. Mapping. The mapping F from the set of F. From the set of edges lead to the set of edges. Just E to the vertices B. Vertices B. Such that such that E belongs to capital E. Is associated pair of elements E. Associated. A pair of elements E. Pair of elements. Pair of elements of E. In the graph called undirected graph, each edge. So here EK is associated with the unordered pair of vertices VI and VJ. VK is associated with a pair of vertices. Pair of vertices. Pair of vertices. VI and VJ. VJ. Where VI, VJ are called edges of vertices of V. Where VI, VJ are called VI and VJ are called N vertices of edge. N vertices of edge. Space. No, definitely. Graph is said to be directed graph or digraphs. G, E, comma, E is said to be undirected only directed, or diagram. uh, Diagram. If a direction is associated with the direction associated with each edge of the glass, each edge of the glass, each edge of the glass. In other words, the mapping from E to versus now EK here, EK belongs to E and VI VJ on order pair. VI VJ can be considered a two-way road with the traffic flow permitted in both the directions. So VI and VJ from V, VI and VJ of axis of V. So when there is a heavy traffic, there may be multiple telephone lines between computers in a network. The model such networks, they need multiple parallel unknown networks. Another definition. Definition. A multi-graph GUG, a multi-graph G, V comma U consists of set of V, consists of a set V, consists of set V of vertices, a set E of edges, a set E of edges, and a mapping F, mapping F, from E to U comma V, such that U comma V belongs to V, and U is not equal to V. It's not equal to V. The edges E1, E2, EI and UJ are called multiple. The edges, yes, EI and EJ are called multiple. Or parallel edges, If F of E1 equal to F of E2. Next definition. An edge joining a vertex to itself. An edge joining a vertex to itself is called a loop. is called a loop. It's called a loop. A graph is said to be simple if it has no loops. A graph is said to be simple if it has no loops and multiple edges. Multiple edges. So no loops are not allowed in a multi-graph. We introduce pseudo-graph. Which is more than multi-graph on LLC. Next definition. Next definition. A pseudograph. Previously, here be silent. I have to read as a pseudograph. G you come on. Consists of a set V. Consists of a set V of vertices. A set E of edges. And a mapping F. A mapping F from E to So U comma V, that means U comma V such that U comma V is belong. For some U belongs to V. If F of E equal to F of V equal to U comma V. Then E is called a loop. Is called a loop. For example, so V1, V2, V3, V4 is an undirected graph. Graph. Undirected graph. V1, V2, V3, V4. This is directed graph. DG means directed. That means next one. V1, V2, V3, V4. This is known as multigraph. And this is known as multigraph. Next. V1, V2, V3, V4. This is known as pseudograph. As P, S, V, U, D, O. It's P silent. Pseudograph. Next paper. Definition. Definition. A graph whose vertex set V is a graph whose vertex V is finite. But edge set E is empty. But edge set E is called a null graph. Set E is empty. Is called null graph. Is called null graph. A special type of null graphs consists of a special type of null graphs consists only one vertex and no vertex. Only one vertex and no edges. No edges. For example, V1, V2, V2, V5, V3. These are all null graphs. Next, incident and degree of the vertex. Incident and degree of the vertex. Incidence and degree of the vertex. Your vertex. Incident and degree of the vertex. Definition. In a graph, two vertices are said to be adjacent. V comma is said to be adjacent, adjacent, adjacent. If they are connected by an edge, if they are connected by edge, connected by edge, and connected by edge. There is an edge E equal to U comma V, connected with vertices U and V. Then U and V are called U1 are called adjacent to each other, adjacent to each other, adjacent to each other. And E is called incident. E is called incident. E is called incident. Is called incident. Incident is called incident. With the vertices U and P. With the vertices U and P. U and P. Then U and V are called endpoints of edges U comma V. So two non-parallel edges are said to be adjacent if they are incident on a common vertex. And definition. Let G U comma be a directed graph. And G V comma E be a undirected graph. Undirected graph. Undirected graph. And Vi belongs to E. Vi belongs to E. The degree of the vertex Vi, degree of the vertex Vi, degree of the vertex Vi, denoted by Vi, denoted by dVg is the number of edges incident on Vi. The number of edges incident on Vi. On Vi plus twice the number of lobes. Plus twice means two. Twice the number of lobes. Number of lobes. At Vi. At Vi. If G is a simple graph, degree of Vi is simply if G is a simple graph, then degree Vi is simply then the degree simply the number of neighbors surrounding Vi. BDS means neighbors surrounding Vi. Surrounding Vi. Next. Definition. Okay. A vertex is said to be a vertex is said to be a vertex is said to be even or odd according even or odd according its degree. Its degree is an even or odd number. Is an even or odd number. Even or odd. A vertex of degree is 0. A vertex of degree. A vertex of degree 0 is called isolated vertex. Is called isolated vertex. Isolated vertex. Consequently, isolated vertex. The follows: isolated vertex is not adjacent to any vertex. This is not adjacent to any vertex. Adjacent to any vertex. A vertex is called pendant. Vertex is called pendant. A vertex is called pendant. If and only if it has degree 1. IFF means if and only if has degree 1. It has degree 1. Consequently, pendant vertex is adjacent to exactly one other vertex. A pendant vertex. A pendant vertex is adjacent to exactly one other vertex. Exactly one other vertex. Other vertex. One other vertex. So example. A, A, B, C, D, E. Yeah. So if you reverse based on the so one theorem based on these concepts. Theorem 7.3.5. 7.35. The sum of the degree of the sum of the degrees of all the vertices statement. The sum of the degrees of all the vertices, all the vertices, all the vertices. In a graph is twice. In a graph is twice. The graph is twice the number of its vertices. Number of its vertices edges. Proof. Proof. Let G be a graph with n vertices. Let G be a graph with vertices. Vertices V1, V2, etc. And E edges. Since every edge is incident, every edge is incident with the two vertices. Vertices. Incident with the two vertices. It contains two to the sum of the degrees. It contains contributes two to the sum of the degrees of the vertices of G. Sum of the degrees of the vertices of G. Hence the sum of the degrees sum of the degrees of all the vertices all the vertices in graph G is in graph G is what is the number of edges in G? What is the number of edges in G? That is sigma equal to 1 to n summation sigma equal to 1 to n degree vi equal to ND. VGI equal to 2. Since tells that several people, the result is known as first theorem of graph theory. Theory is often called the handshaking lemma. This is often means frequently, known as handshaking lemma. Handshaking lemma. Handshaking lemma. The total number of hands shaken must. So this completes the proof, hence the hands proof. Next. Theorem 7.3.6. 3.6, most important. Second theorem. In any graph G, the number of vertices of odd degree, the number of vertices of odd degree is always even. Yes. Always even. Even degree in graph G. So proof. Consider the previous theorem. We consider the vertices with the odd and even degree. We consider the vertices with odd and even degree. And the graph G separately. Then the quantity in the left side, the left side, quantity left side. The previous thing expresses the sum of two sums. Expresses the sum of two sums. Can be expressed sum of two sums. Sum of two sums. Of two sums. taken over the vertices even and odd degree respectively. Sigma I equal to 1 to n. D of Vi, D of Vi plus sigma. This is sigma D of Vi. Of Vi is given plus sigma D of Vk. This is odd. This is equation number 2. So first theorem is 1. So by LHS of 7.2 even number, the two expressions of RHS 7.2 must be both the same. First term is, that means sigma odd D of Vk equal to an even number. And even number. Equation number 2 consider. So this is equation number 3. Equation number 1, what is the one? Summation sigma I equal to 1 to n. And degree of Vi equal to 2e. This is equation number 1, 2, 3. So the total number of terms, since D of Vk is odd, so each D of Vk is odd. The total number of terms in this sum, the total number of terms in this sum must be, even to make the sum, even to make the sum and even number, sum as even number, This completes the proof, hence the theorem. Next. Next thing, 7.4.3. This is most important. 7.4.3. Statement. In any directed graph, G, V, comma, E, the sum of the out degrees degrees of all the vertices is all the vertices is equal to the sum of the is equal to the sum of sum of in degrees of the vertices in G. Degrees vertices of the vertices in G, which is equal to the number of degrees in G, which is equal to the number of edges in G. That means, and symbolically, small v belongs to n, degree v minus that equal to sigma v belongs to capital V to n, degree v plus that equal to modulus of E, mod E. Proof. So each edge has an initial vertex. Since each edge has an initial vertex. And initial vertex and a terminal vertex. Terminal vertex. The sum of the degrees the sum of the in degrees and the sum of the out degrees. Sum of the out degrees. Not the out degrees of all vertices in a directed graph. Of all vertices in a directed graph. Directed graph. Are the same. Both of these sum are the numbers of edges in the graph. Both of these sums are the Sums are the numbers of degree in the graph of degree in the graph. Next, an isolated vertex is an isolated vertex is one in which the in degree and the out degree are both equal, and the out degree both equal. Degree both equal. Equal to 0. Both equal to 0. In a directed graph, a vertex V is called a pendant vertex. A vertex V is called a pendant vertex. Pendant vertex is pendant vertex. If it is a degree 1, if it is a degree 1, degree 1, that is d plus of plus d minus of b equal to 1. This completes the proof, hence proof. So next 7.4 definitions. 7.4 definitions. Definitions. 7.4.7. 7.4.7. 8. 7.4.8. Examples and definitions. And definitions. Next 7.5. And all definitions. Definitions, most important. I have to do it as homework. HW means homework. So, thank you very much.